Okay, this is an FRQ that was given in 2004 that shows both the multiplication principles and the complement principles. So two antibiotics, oh, I should make one other comment. I used to give this as a test question. Scores tended to be low on this, so I decided it should be part of the notes as opposed to the test. So two antibiotics are available as treatments for common ear infection in children. Antibiotic A is known to be cure the infection 60% of the time. Treatment with antibiotic A costs $50. Antibiotic B is known to effectively cure the infection 90% of the time. Treatment with antibiotic B costs $80. The antibiotics work independently. Oh, that's important. Because they work independently, we know we can do some multiplication. We can use a multiplication principle. Both antibiotics can be safely administered to children. A health insurance company, oh, this tells me my contacts. So we have children, earaches, and a health insurance company intends to recommend one of the following plans for treatment for children with this ear infection. Plan 1, treat with antibiotic A first. If it's not effective, then treat with B. Plan 2, treat with B first. If it doesn't work, then treat with A. If a doctor treats a child with an ear infection using Plan 1, what's the probability the child will be cured? So let's look at that. So Plan 1 says we're going to do A first. Plan 1, A, and if it doesn't work, we'll use B. Well, first off, how often did A work? Well, when we looked, A worked 60% of the time. Great. We also know B works 90% of the time. And if I add those two, I get numbers greater than 1 point. I get numbers greater than 1, so that can't be it. And so if I'm using Plan 1, I'm always going to have to give drug A, because that's where we start, was administering drug A. But do I always have to give drug B? And the answer is no. I only give drug B if A doesn't work. How often does an A work? Oh, 40% of the time. So 0.6 plus 0.4 times 0.9, because this is a probability of A working plus the probability that it doesn't work, in which case I administered B. When I did that, I find out, oh, it works 96% of the time. So Plan 1 has a 96% cure rate. And really, you didn't need to show all that information. If you just showed this, you'd be great. Then we have Plan 2. Well, Plan 2 is just the reverse. Instead of starting with A, we're going to start with B, and then we'll go to A if necessary. Well, how often does Plan B work, or drug B work? 90% of the time. And drug A works 60% of the time. Once again, I can't just add those two probabilities because I'm greater than 1. How often will I, if I do this first, how often will I have to do this? Oh, I only do this if drug B doesn't work, which is 10% of the time. And that also is 0.96. So both treatment plans have exactly the same cure rate. They cure 96%. So, all right, the health insurance company is not going to make a decision based on cure rate. Let's talk about cost. What did they tell us about costs? Drug A was $50 and drug B was $80. So let's look at the way this works. If we look at Plan 1, I know I'm guaranteed, because I'm going to administer drug A, I'm guaranteed to having to spend $50. But 40% of the time, it doesn't work, and I'm going to have to spend $80. And if I do that, I end up getting $82. And really, I should be writing the sentence, on average, we would expect to spend $82, or in the long run, we'd expect to spend $82 if we were going with Plan 1. With Plan 2, we're going to start with B first and then A. Well, drug B cost $80 and drug A cost $50. But I'm not going to have to use drug A all the time. I only have to use it 10% of the time, which means Plan 2 in the long run costs $85. For any one patient, it's either going to cost $80 or it's going to cost $130 for any one patient. All right. But on average, what do we expect to spend? We expect to spend on average $85. And you're like, well, wait a second. How did you say it's going to cost for any one patient either $80 or $130? Well, if drug B works by itself, I'm going to spend $80. But if I have to buy drug A as well, it costs $130. But the expected cost is $85. Here, drug A, I'm either going to spend $50 or $130. $50 if it works if drug A works, but if not, and I have to go to drug B, I'm going to have to spend an additional $80, so it costs $130. But on average, we expect to spend $82. So what we find is Plan 1 ends up being cheaper than Plan 2. And the thing is, we have a health insurance company that wants to make a recommendation, and there's no difference in the cure rate. So what are they going to recommend? They're going to want to save money, likely. So we're going to have to define it, because both treatment protocols have the same cure rate. So I've addressed the cure rate. The health insurance company will recommend treatment 1 over treatment 2 in an attempt to minimize costs, because the $82 is cheaper than the $85. Now, if I were a parent, I know earaches are extremely painful for kids. And I know that drug B has a 90% cure rate. So I would probably go with drug B because I can administer it, and 90% of the time they're going to get well the first week. So that's a much faster cure time than with Plan 1. But from a cost standpoint, which is where the insurance company is coming from, I'm going to recommend Plan 2. Okay? All right. There's that information. Thank you.